We're going to take a look at a sheet that you have that I believe is titled AP Prep Formal Definition of the Derivative. This really has nothing to do with product rule or quotient rule. I just need some place to fit this in. We have a bunch of crazy looking limit problems that we need to deal with. And as you look at them, they should remind you of like some formal definition of the derivative problems. Like in number 1, you could FOIL and FOIL and FOIL and simplify and cancel, and that would give you some sort of derivative. Not totally sure how we would deal with number 2, but these should look like the formal definition of the derivative. Let me remind you of the formal definition of the derivative. We have f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. That's our formal definition of the derivative, how we started off our chapter on derivatives. Problems like what are on this sheet is how the AP exam tests if you know the formal definition of the derivative. They can't give you a multiple choice question where they say, here's a function, use the formal definition of the derivative to find the derivative, because if it's multiple choice, what's to stop you from just using all those shortcut rules? What we're going to do here is kind of go in some strange directions with these things. We need to recognize what the problem is really asking us to find, and then we'll just find it using our shortcut rules. Here's what I mean. Take a look at number 1. We have the limit as h approaches 0 of x plus h to the 4th minus x to the 4th over h. And I hope you can look at this and realize, yeah, it's in exactly the same form as our formal definition of the derivative. The function that I first plugged x plus h into and then plugged x into is just the function f of x equals x to the 4th. And what number 1 is doing, if we were actually able to go and expand it and then simplify and take our limit and all that stuff, this is really saying, find the derivative of x to the 4th. Problem number 1, the way it's written, is really just saying, find the derivative of x to the 4th. If you don't believe me, if we said f of x equals x to the 4th, then I can go and use that formula, f prime of x equals the limit as h approaches 0 of f of x plus h, that's x plus h to the 4th, minus f of x, that's minus x to the 4th, over h. That's exactly what I'm getting over there. Now, they're not expecting you to actually go through all the algebra to solve that. They want you to recognize this is saying, find the derivative of x to the 4th, and then find the derivative of x to the 4th, the best way you know, which is just using our shortcut rules. The derivative of x to the 4th is 4x cubed, which means this limit over here is going to give you 4x cubed. Once again, that limit was really a kind of a sneaky way of asking, can we find the derivative of x to the 4th? Well, sure we can, and the derivative of x to the 4th is 4x cubed. We're going to jump around a little bit on this sheet. I think for next year I need to reorder these problems a little bit. I'd like to go down to number 4. I hope you can look at number 4 and realize that this is really just the formula that will find the derivative of what function? This is really saying f of x equals the tangent of x, because here's my f of x plus h minus f of x over h. And this problem is asking us to find the derivative of the tangent of x. Well, what is it? What's the derivative of the tangent of x? Derivative of tangent of x is secant squared x. And there we go. One more like this. take a look at number 7. What is the function that 7 is asking us to find the derivative of? Well, let's see. This is f of x plus h minus f of x over h. It wants us to find the derivative of f of x equals 2 over x to the 5th. And I'm going to rewrite that as 2x to the negative 5 so I can just use power rule and not have to use quotient rule. Take a moment, go find your derivative, and when you're done, don't leave any negative powers. F prime of x is going to equal negative 10 x to the negative 6, which should be negative 10 over x to the 6th. Even though these are limit problems, they're really asking you to find the derivative because that particular limit you're given is the definition of the derivative. There are two other versions of this, though, that we need to look at. Let's go back and take a look at number 2. Number 2 is sort of like our formal definition of the derivative. It's just that in place of x, I have a 2 pi over 3. What a problem like number 2 is saying is, let's look at the function f of x equals the sine of x, and let's find not f prime of x, but instead let's find f prime of, well, that thing that I have in the place of x. Let's find f prime of 2 pi over 3, which means let's find our derivative of the sine of x, and when we're done, let's plug in 2 pi over 3 to that. Well, okay. The derivative of the sine of x, you should know, is the cosine of x. If I want to find the derivative at 2 pi over 3, that means go find the cosine of 2 pi over 3. What are you going to get out of that? Let's see, cosine of 2 pi over 3, that should be negative 1/2. If we have a formal definition of the derivative problem, but instead of an x, we have some number where the x normally would go, that problem is really just asking us to find the derivative at that specific x value that's in the place of x. Let's take a look at number 5. See if you can rewrite problem 5 the way I started problem 2, by saying what the function is and then saying what we're looking for. The video is going to pause for a moment. I think our function is f of x equals x to the 3rd, and I want to go find f prime at, well, what's in the place of the x's? A 9. I want to go find f prime of 9. Go do it. Go find your derivative and then plug in 9. F prime of x equals 3x squared. F prime of 9 is going to equal 3 times 9 squared. 3 times 81, I think that is 243. 243. I'd like you to take a look at 8 and see if you can do all of number 8. So let's see, I've got a 4 where my x would normally go. So number 8 is saying f of x equals the cosine of x, and it wants us to find f prime of 4. Okay, well, f prime of x is going to equal negative sine x. So f prime of 4 is going to equal negative sine 4. It's not a great angle from around the unit circle, so I'm just going to leave my answer like that, negative sine of 4. Here's one last thing we need to look at on this sheet, and basically these 3 different types of problems are the 3 ways the AP exam can test you on the formal definition of the derivative. I will give you all 3 of those on your Unit 2 test. We need to deal with problems 3 and 6. And what I hope you remember is there's also an alternate definition of our derivative. Our alternate definition of the derivative says f prime of c, the derivative at a particular x value, equals the limit as x approaches c of f of x minus f of c over x minus c, which is exactly the form that I see in problem 3 and in problem 6. Here's what I mean by that. In number 3, it's like I'm saying my function, f of x, is the square root of x. This number over here is f of, well, whatever my c value is, which is the number over here, the number over there, f of 4, which, sure, square root of 4, that's 2, things are working. This problem is saying f of x equals the square root of 4, no, the square root of x, sorry, not 4. I want to find f prime of 4, the derivative when x equals 4. F prime of x is going to equal 1/2 x to the negative 1/2, or 1 over 2 root x. So f prime of 4 is going to equal 1 over 2 root 4, 1 over 2 times 2, 1/4. One more of these. Number 6 is also in that form of the alternate version of the derivative. I'd like to see if you can do number 4. Figure out what the function is, where you're asked to find the derivative of it, and then go find the derivative. What is the answer to number 6? I think I might have said 4. I didn't mean 4. I meant 6. Okay, so in 6, it's like saying f of x equals the cosine of x. Let's find f prime of pi. Well, f prime of x is going to equal negative sine x. F prime of pi, then, is going to be negative sine pi. Sine pi is 0, so negative that. Still going to be 0. On your chapter test, the good news is I will not make you actually calculate derivatives using the formal definition, go through all the foiling and simplifying and all that, but I will make you recognize problems that are asking you to find the formal definition of the derivative in one of these 3 forms, actually in all 3 of these 3 forms.